Page 210 in your textbooks, you did numbers 13 and 14 at the very bottom of the page, evaluating g of f of x, or finding g of f of x, and including the domain with your answer. And then in just a moment, we'll get to page 220, where you did numbers 29 to 34. So 210, 13 and 14, page 220, numbers 29 to 34. Good. Let's take a look at these. Number 13. We were given a function f of x is square root of x minus 1. And we were given g of x is 2x negative 2. And again, they asked specifically for g of f of x. How should I start this off, Kendall?
You do g of the square root of x minus 1.
All right.
And then do 2 times the square root of x minus 1 minus 2.
Good. And we're done. There's no other way to simplify it. We do need to account for the domain. And the way we account for the domain, remember, is to find the domain of both given functions. What is the domain of f of x? Michael?
1 to infinity.
1 and bigger. You can't go anything smaller than a 1, but as long as you've got something 1 or greater, we're okay. How about the domain of g of x?
All right numbers.
And what does the domain appear to be for this function?
1 to infinity.
Also 1 to infinity. We're going to take all three of those domains and make sure that we have excluded every value that's cut out of all the domains. However, Michael, the resulting domain really is
1 to infinity.
1 to infinity. And so there's my resulting function, 2 times the square root of x minus 1 minus 2, and the domain is 1 to infinity. How many had that for number 13? All right, questions? Let's take a look at number 14, where we were given that f of x is equal to the square root of x negative 7. And g of x is 3x positive 1. I didn't put a lot of creativity into these two, apparently. But Maddie, we did need to find g of f of x, and walk me through. We should notice that g of x has what domain limitation? Genesis? What's the domain for g of x? Yeah, that's if you don't see it, it's all real numbers. What about f of x?
7 to infinity.
Right, as long as you plug in at least a 7 or bigger, right? Bigger is fine, smaller is not, so 7 to infinity. But here, it's still going to be, so there's really only one limitation the whole way through, so that's our domain, 7 to infinity for our domain. And how many had that for number 14? All right, questions on number 14? All right, let's take a look at page 220 now. Turn there in your textbooks, page 220. Numbers 29 to 34. Number 29, they gave you f of x was a negative x squared, negative 6x, positive 4. They gave you that gx was 7x, negative 9. They wanted you to find, first of all, for number 29, f plus g of x. What do we have to do, Audrey?
You have to add
Just add them together, and what do we get?
negative x squared plus x minus 5.
There we go, negative x squared, positive x, negative 5. How many had that for number 29? All right, number 30. Want us to find f minus g of x. What do we have to do there, Brandon?
Subtract, but you add by changing the signs. Add the inverse.
Add the inverse. There we go. Third tries the charm. All right, add the inverse. If I just wait long enough, he's going to stumble upon it. Add the inverse, and what did you get when you added the inverse?
Negative x squared, negative 13x, positive 13.
Excellent job. Negative x squared, negative 13x, positive 13. How many had that for number 30? All right, number 31, they give you f of x is x cubed, positive 5x squared, negative 14x. They give us that g of x is x positive 7, where x can't equal, or when, oh, we're evaluating. Okay, when x is negative 3, gotcha. My brain was initially reading that as a domain limitation. When x equals negative 3. So It just said to evaluate the function. It didn't say to actually find fg of x, though the textbook did, my sample answer key did. It didn't say to find fg of x and then evaluate. It just said evaluate. Did you happen to find the combination function by any chance, Abby? Did you find fg of x per chance?
Yes, with the -3.
Well, I'm just saying without the -3. Do you just find fg of x and actually multiply those two polynomials together? Did anyone do that? You did? What did you get? Good. And you didn't have to do that, but if you wanted to, and you could have done this, you could have gotten x to the 4th, positive 12x cubed, positive 21x squared, negative 98x. Then you could have plugged in -3 into that function, and you would have gotten 240. But that's not the way I would want to do it. How would I want to do it? Let's go back to Abby.
I just plugged the -3 in for all the x's and then multiply the two equations.
Good. I found f of -3, or I would have done it this way, and this is what Abby said she did. She found f of -3, plugged that in, that's what, -27, positive 45, positive 42. So that gives you what? 60?
Yeah.
Yeah. And then you found g of -3, and that's a lot easier, that's just 4. And so when it said find fg of -3, well that just means you multiply the 60 by 4 and you'll get the same 240 that Maddie got. It's a little quicker, I think, doing it this way than the way that Maddie had to do it, or chose to do it. The same answer either way. Now, if it had said, find the combination function fg of x and then evaluate when x is -3, then you have to do the way Maddie did it. Do you see the difference in the wording? But it only said to evaluate. It didn't say you had to find it. Number 32. Well, we already found f of -3 and g of -3. So it says to find f over g of -3, we could just divide, class, and get 15. Or if you happen to divide f of x by g of x to find fg of x, anyone find that? And actually find fg of x. Or f over g, excuse me, f over g of x. You did find it.
X times the quantity of x minus 2 where x can equals -7.
Good, x times x -2, or if you distributed x squared -2x, where x cannot equal 7. But again, same thing, you plug in the -3 into that, you're still going to get the 15. So a couple ways we could approach numbers 31 and 32. Questions on those? How many got 15 for number 32? All right, excellent. And I don't think I asked, how many had 240 for 31? All right, excellent. Number 33, they gave us f of x is 5x squared, -15x, -7. They gave us that g of x is 4x, -9. This one looks like it's going to be a pain because they want a composed function. They wanted f of g of x. By the way, what's the other way we could write f of g of x? Audrey? Anyone?
F of g of x.
F of, and then in parentheses, g of x. These mean the same thing, right? But if we want to find f of g of x, that means we're going to have to take the g of x and plug it into the f function. How many different places does it have to go in, class? 2. It has to go in here and in here. Here you're going to have to square it, then distribute a 5. Here we're going to have to distribute a -15, and the -7 just kind of comes along for the ride. I'm going to need a little more space, so let me erase these past answers here. And let's see how we do on this. For f of g of x, we're going to take 5 times the 4x -9 squared minus the 15 times 4x -9 minus 7. What do we get when we square the binomial? Genesis?
16x squared. Positive 81.
You can look at your paper or use your calculator, either one if you need to.
72. Positive 72. Negative 72. X.
There we go. All right, and then when we distribute the -15, what do we end up with here, Michael?
It's on my drum. -60x plus 135.
All right, minus the 7. Of course, we do still need to distribute the 5, Kendall. guess you didn't do this last night.
105.
All right, minus the 60x plus the 135 minus the 7. A lot of combining. What did you get for your answer? Let's come back to Genesis, assuming everything looked good. Everything looks good so far? Okay, never mind. Let's call on Abby.
I got 80x squared minus 420x minus 263.
And no, I didn't get my book doesn't have a negative 263. Someone get something different at the end? What did you have?
533.
They have a plus 533. I hadn't actually done the math yet, so relying on the textbook, but I'm going to assume they're correct in this case. All right, and they wanted you to also include the domain. Well, class, thoughts on the domain of f of x?
All real numbers.
All real numbers. G of x?
All real numbers.
The apparent domain?
All real numbers.
So the domain is all real numbers. That's what we should have ended up with. How many at least had the domain was all real? You figured out the domain was going to be all real numbers. All right, questions on that. A lot of math. And that was a pretty busy function there. Questions? All right, and the last one you had, number 34, takes the same two functions and wants you to find g of f of x. This is at least going to be easier, I think, to find g of f of x, because we're finding g of the 5x squared negative 15x negative 7. But it's a lot easier to plug that into the g function. What do we need to do, Brandon?
Put that into the x, so 4 times 5x squared negative 15x negative 7 minus 9. And then distribute the 4 to get 20x squared negative 60x minus 28 and negative 9. And combine to get 20x squared negative 60x negative 37.
There we go. Let's combine there at the end. We get a negative 37. Apparent domain, class?
All
All
real
real
numbers.
numbers.
And since those are both all real numbers, this is still all real numbers, so yeah, the domain thing. We worked on it yesterday, and then in the homework it was kind of boring. But anyway, questions on this? Anyone got that for number 34? Got a lot easier math that time. Questions? All right, set your books aside for a moment. Let's do a little bit more classwork, practicing with our functions. I'm going to give you three functions. Let's start with the function f of x is 7x negative x squared. And yes, I'm still on the screen. Let's take a function g of x is 3x positive 4. Let's find a function h of x, and that's going to be the square root of x plus 5. I'm going to do all evaluations here, so do these the fast, easy way, for pity's sakes. F plus g over h of 4 is where we'll start. I got a few more for you. those first two didn't work out as nice as I might have liked them to. And who writes these? Back if I can pin these on anyone else. Nope, I don't think I can. My bad. I'm not OCD.
I am, thank you.
You're welcome. I tried. I was like, it's still bubbling, Mr. Nadasky. I'd be like, I tried. Nobody's perfect. But then you'd be insulted if I said that. So. Etc. All right, so most of us are about done. Questions? Well, actually, let's start here. Was anyone perfect? You have all of these correct. All right. Any of these say, okay, how did you get that? Any questions on any of these at all? All right, so the ones we didn't finish or maybe didn't get correct, he's like, oh, I see what I should have done. All right, any questions on functions? All right, clear your desks. Except for a clean sheet of paper, pencil, calculator. Clean sheet of paper, pencil, calculator. Everything else away. Let's go ahead and wrap this. Well, kick back to a couple sections we've done on functions. Let's take a quiz. First, let's name at the top of that clean sheet of paper, along with today's date, which is 2/4/22. 2/4/22, today's date. And this is quiz 24. Yeah, quiz 24 on 2/4. All right, quiz 24. Let's go and take a look at the quiz together. I'll let you get started on that. Numbers 1 through 6 are all based on those first two functions at the top. Okay, so given those two functions, find, and notice the first four are rather vague functions, right? They still are defined in terms of x. Number 5 and number 6 are finding a function of the other, but we're evaluating it at 3 in both cases. Then for numbers 7 and 8, we're going to leave them vague, if you will. Make sure you include the domain with your answer for both f of g and g of f of x. And then for numbers 9 and 10, I got another pair of functions for you, and find those composed functions also. All right? At your seats, you may begin. Be sure to use this quiz copy as a cover sheet. sure you're using that quiz copy to keep your work covered. Somebody sounds like they're dying out there. May or may not need rescue breathing, CPR. Any of you certified?
Nope.
I think my certification lapsed. I think I'm off the hook. I'm just kidding. If I felt they really needed it, I would go. You're certified. Okay, so we got Genesis. She's certified. She's an adult. Michael's certified. Is it your lifeguard? No. Ever been a lifeguard?
No.
You just have a hoodie that says lifeguard?
Yeah.
You're a liar. Just kidding.
Liars.
All right, get back to work. Get back to work. Sorry, I'm distracting you from the quiz.
Extra time, 10 minutes.
Take quiz. 1 minute. One extra minute. Once you finish, turn your paper over and sit quietly. another minute or so to be finishing up. About another minute. We're going to open up your notes to a new section. Now, I suppose if you're watching on YouTube and you need a little bit longer, I'm going to pause the video, but we're going to progress in the time we have left this hour and introduce what we're going to be talking about most of next week, and those are quadratic functions. Next section of your notes, quadratic functions. I mentioned before the last test, as we first looked at this idea of domain and range and limitations on things, with absolute value functions and constant functions and radical functions and rational functions. Quadratic functions, I said, we're going to be studying them in a lot more depth later, so I don't want to go into too much depth now. Well, later is now. Now is later, however you want to say it. So let's go and talk about these quadratic functions. First of all, with a quadratic function, you know that the basic form you're looking for is f of x equals ax squared plus bx plus c. Shouldn't shock you because that's the basic form of a quadratic trinomial. That's also the basic form of a quadratic function then. F of x equals ax squared plus bx plus c. You also need to note that a quadratic function is graphed as a parabola. I know that's in your notes from earlier, but let's get it down once again. You know, of course, that the parabola is that sort of a U shape, okay? Now, this U shape spreads outward constantly. It never goes straight up like an actual U. Like the letter U, the sides end up running parallel at the end. A parabola will not do that. The sides will continue to spread outward, okay? So a parabola could be a U that spreads outward, or it could be like this, where again, it just continually spreads outward. As we should already know, this number, this value here is what's going to make a lot of the difference. If the A is a positive value, often a positive 1, at least that's what we like to see, then we know the parabola is going to go upward. And if the A is a negative value, the parabola is going to go downward. All of this so far should be reviewed for you, but let's get in the notes just to keep all of your notes in one spot. We also know that this low point here, or the high point here, is called the vertex. We'll label it with the letter V. Write that term in your notes, the vertex of the parabola. And of course, you remember that we said the vertex is really kind of the defining point as far as the range of a quadratic function. The domain of a quadratic function is infinite. We already said that, limitless, all real numbers. But the range is either going to be vertex up to infinity or negative infinity up to the vertex. And that's what we talked about previously. But I'd always had to give you the vertex, right? And I'm sure all of you, as smart as you are, you felt just a little cheated, like, find my own vertex, thanks. Well, okay, I'm not going to disappoint you any longer. So here's your key. Put a star next to this. To find the vertex. So no more free handouts that, besmirch your character and intelligence and insult you. To find the vertex, I want you to factor out the A, if there is one. Factor out A, if there is an A. And in a really good world scenario, it's a 1 right here. I love it when there's a 1. I don't like having an A. But if there is an A, factor it out. And then you're going to take negative half of B. You're going to factor out the A and take negative half of B. So, in a sense, then we would say the vertex will have these coordinates. Negative half B over A. This shows the A being factored out first. That's going to be the X value of your vertex. The Y value is going to be F of whatever that is. F of that. So you're going to find again, factor out the A if you have to, negative half B, and then take F of that. And that'll tell you the Y value. And that way you can find your own range, find your own vertex. For instance, write this function down. F of x equals x squared, negative 6x, positive 5. Clearly a quadratic function, right? We've got the x squared as the highest power. We want to figure out where is the vertex. Well, for starters, we're going to, if we have to, factor out the A. But thoughts, class? There's no A. I like that. So we're just going to take negative half of the B value. Remember, the B value is this coefficient of the x to the first. By the way, you're familiar with half the B, right? We used to half the B and then square it to complete the square. Well, this time we're taking negative half the B. What is negative half of negative 6, class? Positive 3. And then if I wanted to complete the vertex, I would take f of the 3. When we take f of 3, that means we square the 3, class.
No.
3 times negative 6
Negative
plus 5. And what is the f of x value for the vertex? That's my vertex. Easy enough. Now, how do I apply this to, for instance, graphing the parabola? Well, I want you to consider if we were to set up an x, y, or rather x, f of x table, I'm going to put the vertex as my lead point, 3, negative 4. But consider this for a moment. In a parabola, the way in which the parabola generally functions, you're going to start here, right, with a point, but the parabola is going to open up symmetrically, isn't it? So as you go up a particular unit value, it's going to go outward a particular unit value in both directions. Does that make sense? Or you could say, as you go outward a particular unit value, it's going to go upward the same amount both times. Or if it were inverted, downward. So here's what I'm going to do. I'm going to take the vertex plus and minus 1 for my next 2 x values. If I add 1 to the 3, class, I would get
4.
And then if I subtract 1, I would get 2. So either a 2 or a 4 are going to have the same f of x. For instance, just to back it up, let's find f of 2. Square the 2. 2 times negative 6 plus 5 is negative 3. F of 4 should also be negative 3 because you went backward 1 to the 2. If we go forward 1 to the 4, we should get the same thing. Let's plug that in. We square the 4. We multiply 4 times negative 6. And we add the 5, and that still gives us negative 3. Now, the beauty of this then is I get 2 points for the price of 1. And I don't have to plug in both of these. I pick the easy one. I like 2 better than 4. It's a smaller number. So then I'm going to add another one, vertex plus minus 2 in the x. I'm going to make the small one smaller, 1, and I'm going to make the big one bigger. But I'm only going to find f of one of these. Which one? The 1, of course, because I'm lazy. I don't want to find f of 5. Let's find f of 1. All right, 1 squared. Negative 6 times 1. And plus the 5 gives us 0. By the way, that means those are going to be x-intercepts. And then just for good measure, maybe we'll do one more row of values. Vertex and then 3 more, plus minus 3 here. So make smaller, make bigger. 0 and 6. Which one am I finding f of? 0 for sure. We'll find f of 0. And f of 0 is 5. You can do that in your head, right? So that when it comes time to graph this, this is where we're going to be going next week with all of this. Just do a quick graph grid for now. We've got our f of x function, our f of x axis, x-axis. We start by putting the vertex at 3, negative 4. From here, I'm going to go back to the 2. That's going to be 2, negative 3, and 4, negative 3. 1, 0, and 5, 0. 0, 5, and 6, 5. And that gives me a number of points. We don't need a straight edge, obviously. We could connect to get our parabola to look a lot better than that because I'm not doing it backhanded. But you get the idea? We can quickly get points because of this symmetric shape of the parabola. But again, you've got to know where to start if you're going to graph the parabola. We start with the vertex. Factor out the a if you have to. Take negative half of b. That gives you the x value. Evaluate to get the f of x. Add 1, subtract 1. They're going to share the same f of x. Add another 1 and subtract another 1. That's going to give you the same f of x. Do it one more time, and that gives you, what is that, 7 total points that you should be able to connect to get a fairly nice curve. Now, if your curve actually looks like this, okay, that'd probably be bad, but you'd want to maybe lightly sketch it first, and you could trace over it, make it look really nice and smooth and pretty so that you don't lose points on a quiz or test, right? Let's take a look at another one of these. And maybe I'll actually use the graph grid on this next one because that one looked really bad. All right, write this function down. F of x equals x squared, negative 8x, positive 14. F of x equals x squared, negative 8x, positive 14. Again, if I want to find the vertex, first thing I'd have to do, class, is make sure that the x squared has a 1 in front of it. If it doesn't, what do I have to do? Factor out whatever's there. But there's nothing there, so I don't have to factor it out. Then I need to remember, class, negative half of b. Say that with me. Negative half of b. One more time. Negative half of b. What is negative half of negative 8, class? Positive 4. And then we can evaluate the vertex by finding f of 4. And someone at your seats, find that for me very quickly.
Negative 2.
Good, that was very quick. Excellent. Negative 2. All right, I'm going to go and set up an f of x table. You do this with me there at your seats. Obviously, 4, negative 2 is my starting point. And I'm going to allow the x to go backward and forward 1, and the curve should go up the same amount every time. So what 2 x values am I going to evaluate at the same time? Audrey? 3 and 5. One more and one less than the x value of the vertex. By the way, the next 2 points, I'm going to make the small one smaller and the big one bigger. So what are the next 2 points, Genesis? 2 and 6 should have the same f of x. And then the last set of points we'll have, Abby?
1 and 7.
1 and 7. All right, now which of these do I want to evaluate? F of 3 or f of 5? Class?
3.
Okay, well, let's do f of 3. Someone besides Michael, calculate f of 3. I gotta do. There, oh. Negative 1, okay. I thought I heard negative 1, and then I thought you said something else. I'm like, did she say negative 1/4? That'd be awful. All right, negative 1 is correct. All right, by the way, watch. This is not 3, 5 as a point. These are 2 separate points, class. This is 3, negative 1, and 5, negative 1. Just want to make sure we're clear on how we're reading this. All right, do I want to take f of 2 or f of 6, class?
2.
F of 2, definitely. And f of 2, someone besides Maddie and Michael? Yes. All right, and then finally, class, f of 1 or f of 7? F of 1, definitely. And that's going to give us 7. All right, so you don't have to necessarily graph it. Unless you have graph paper and want to do it, you will need graph paper next week, by the way. But let's see if we can get a little bit better looking parabola this time. And again, it's not x and y anymore, it's x and f of x. F of x means the same thing, obviously, but it's the notation we're using. And we'll plot a point at 4, -2. And then we're going to go 3 and 5 are both going to have -1. So 3, -1, and 5, -1. 2 and 6 are both at 2. So 2, 2, and 6, 2. And then 1 and 7 are both at 7. So 1, 7, and 7, 7. And then we connect the dots. Try to get a nice smooth curve like that. All right, questions on that parabola? All right, questions on the basics of quadratic functions. Again, we're going to study a lot of other things we can do with quadratic functions. We're going to teach you all kinds of shortcuts to make things even quicker than this for graphing next week. But any questions on what we looked at today? All right, your homework for this evening. Choke, gag, etc. I need a drink of water. I got dust in my throat or something. Read pages 199 to 202. Read pages 199 to 202. Kind of a preview of where we're going next week with all of this. Read 199 to 202. On page 209, do numbers 34, 36, and 38. Page 209, do numbers 34, 36, and 38. And then on page 218, do the review 1 through 11 odd. Page 218, the review 1 through 11 odd. Take a look at all of this on Monday. Have a wonderful weekend, and when the bell rings, you'll be dismissed.